Welcome to Physics STPM. A-level student may also find it useful, right? Because it's covered more or less the same syllabus. These are the topics that we will cover for STPM student. Right? We cover physical quantity. Now we are going to kinematics. This one just a summary of what you're going to learn for STPM student. Right? For STPM student, we are divide the syllabus divided into linear motion and projectile motion. Linear motion is just motion in a straight line. Right? So we will define speed, displacement, velocity, acceleration, graph of gradient, how to interpret the graph from the gradient and the area under the graph. And we will go to equations of uniform acceleration. After that, we look at projectile. We will look at the case where there is no air resistance and look at effect of air resistance. We can call this one non-linear motion or motion in two dimensions. Right? No more in a straight line. That's why it's non-linear, not straight line. Right? That's the STPM syllabus. Linear motion, projectile motion. Okay, that is all required. Derive and use equation of motion for constant acceleration. Sketch and use the graph of displacement time, velocity time, and acceleration time for the motion of body with constant acceleration. For Cambridge A-level student, we are just covering 1, 2, 3, 4, 5. Okay. For STPM student, it's more of a revision for them. Most of the things they have learned in SPM. For A-level student, this is required. Yeah, it's good to summarize using mind map, right? To have you understand, make your own mind map, but just realize that on the internet, sometimes there can be mistake there. Right? Like in this case, there's a mistake there. You can find it. Right? Correct. Here. Right? Velocity is a vector, not a scalar. Okay, we will start with kinematics. It's related to motion. Dynamic forces acting on the motion. Give you the reason why it's accelerating. So mechanics is basically kinematics and dynamic. So we'll be looking at equation of uniform acceleration. Right? It's just to whet your appetite, what we'll cover. And then the graph, displacement time graph, velocity time graph, acceleration time graph. And also how to interpret it, read the graph. Right? For O-level and SPM, we are more interested in distance and speed rather than velocity and displacement. Then we look at effect of air resistance. This is the effect of air resistance on uniform velocity. On uniform acceleration. Right? This one now air resistance. We look at a case where there's no air resistance first. Then motion in the plane, two dimension. Right? There's your experiment you can carry out in your lab. Okay, so our first assumption is air resistance is negligible. Negligible means zero. Scalars, distance, speed, vectors, displacement, velocity, and acceleration. So these are the vectors quantity that we will be covering for this topic, kinematics. Okay, that is the journey. We start from A, we end at C. So distance, right? We can use a symbol X or S, length of travel. And this one travel 4 meter and 3 meter. Displacement is the distance moved from a fixed point in a specific direction. So in this case, if you start from A to B, then stop at C, then displacement we are interested in where you start and where you stop. Okay, let's look at the example. Right? If the person walk from A to B and finally to C, right? Walk from A to B 4 meter, then from B to C 3 meter at 90 degrees. Then the distance you just add up 3 meter, 4 meter plus 3 meter is 7 meter. That's the distance traveled. Don't worry about direction at all. Whereas displacement, we have to know where it starts, where it stops. You join the line, so that's the displacement. Right? Where you can take Pythagoras theorem, 4 square plus 3 square, and then you square root it, you get 3, 4, 5. Then you need to find this angle. Right? Because displacement is a vector, you need to know not only the magnitude, the size of the distance, you also need to know the direction, where is it moving, which direction. Right? So we can use cos theta. Right? This triangle, triangle. Cos theta is just this side, opposite over hypotenuse. So 4 over 5, and use calculator, calculate it out, 37 degrees. Linear motion, we have a starting point, call it 0, and then we have an x direction, right? And then remember, displacement is a vector quantity. So object move forward in the x direction, we call it positive. And it's going to the right, positive direction. If we move to the left, negative direction, or minus x. Yes, provided we are interested in vector. Scalar, we are not worried about the direction. Speed and velocity. Speed is defined as the rate, right? The key term is rate of change in distance. Velocity is defined as the rate of change in displacement. This is displacement. This one is distance with time. Right? And sometimes we use delta x, change in displacement, time interval. The change in time displacement during this time. And mathematical form, that's what we will be using. More precise, we use mathematics. Rate, we use the calculus, dx dt. Or a small change in x divided by a small change in t. Unit, x is meter, t is second, so unit is meter per second. We can cross multiply, then we got d equals to delta times delta t is delta x. Distance travel is just a velocity times your time. Uniform velocity, what does it mean? It means that the change in displacement in equal time interval is the same, or the change in distance with time is the same. Same if it's a straight line, we can call uniform speed also, or steady speed. Okay, so same time, same distance, same time, same distance, or same displacement. Then you need to know your displacement time graph. If it's a straight line, right? Position is American, and we call it displacement. So change in distance, there's a change in distance, there's a change in time or time interval. So we can describe it as displacement increase as a steady rate. Right? It's constant, the gradient is constant. Or we can write a calculus notation, dx dt of delta x delta t. So we call this uniform velocity. It is a straight line graph for displacement, or it can be distant graph. distance against time is still distance against time uniform speed. Is displacement against time, then is velocity, uniform velocity. So the gradient is 50. That is your 50. This is 5, 55. And then this is 20 to 22. So gradient is 10. 30 divided by 3. 10 meter per second. So that is the surface speed or uniform speed. Or uniform velocity is 10 meters per second. Then how to represent the velocity time graph? Well, whether it's speed or velocity, it doesn't matter because there's no direction here. It's still the same. Right? We have already calculated the speed. The constant speed is 10 meters per second. We just put a value, draw a horizontal line. That's velocity time graph. Then we need to know that, right? Area under the graph is given displacement. As you can see from this equation, velocity time graph, this one is the displacement. Right? So you should be able to read the graph. If it's constant distance, constant distance or constant displacement, as the time increases, that means the object is not moving, stationary object. So displacement is 5 meters from the origin. That's all we know. Right? And it's not moving, so it's stationary. Object is at rest or stationary. Non-uniform velocity, right? It's normal straight line. Remember, velocity from displacement time graph, gradient of tangent to the curve give the velocity. So the gradient, you can see that this is the slope or gradient increasing. So we can say non-uniform velocity or it's accelerating. So to find the velocity at any time, we find the gradient of tangent to curve. That tangent, right? Touching at that point there to find the velocity at point P or at point Q. Right? The tangent just touches the curve at Q. So we see that the gradient increases, so velocity increases. Average and instantaneous velocity speed. Average speed is the total distance moved divided by time taken. Right? Or if it's uniform acceleration, we can use half u plus v. Instantaneous is just at a particular time. The instantaneous speed is the speed at a particular time that the object is traveling. So average, right? That's a symbol. Average format. That's the best symbol. Average total distance over total time. X over t. Meter per second. This is uniform acceleration. How to find the average velocity? Right? The car reaches the same place. Right? That's the meaning of average velocity. It reaches the same place. This is uniform velocity. Right? It takes a time to reach a place. So average velocity is basically the idea is you will reach the same place if you travel at uniform velocity. It means you are assuming it's a straight line. Constant speed or constant velocity, you reach the same time. So displacement is area under the graph. So it's half u plus v times t. Right? Or area of the trapezium. And average is the idea of average is average velocity or average speed is because travel at a constant speed there. And you reach the same time. So it means that we want this area equals to area of trapezium, right? Or we just take the area of this rectangle is the average speed times the time. Time and time the same. So that's how we can show that if it's uniform acceleration, then your average speed is half u plus v. Acceleration. Now we have defined distance, displacement, speed, and velocity. Now we define acceleration. Rate of change in velocity. We want to write in mathematical form. A equals to B minus U over T. V is the final velocity. U is the initial velocity. T is the time interval, or the time for the velocity to change from U to V. Non-uniform, you cannot use this formula. With non-uniform acceleration, you have to use calculus dv dt or delta v delta t. Right? And then remember, this is a vector equation. This is velocity, this is acceleration. Every time is a scalar. Okay, so you Google, you will find under acceleration is moving. Unit of acceleration, go to the formula. Right? Velocity v and u is the same. Meter per second. Time is second. So it's meter s minus 2. That's the unit of acceleration. Let's look at this is a uniform velocity graph or velocity time graph. Right? Or we say velocity increases at a steady rate 2 meters for every 1 second. Okay? You can take a small triangle there. Okay? A small triangle. 1 second, 2 meters. This is 4. Right? Another 1 second, 2 meters. Right? This is 8. So 1 second, this is 3. 2 to 3 is 1 second, 2 meters. That's what it means. 2 meters per second for every second. Okay. Or acceleration. Right? You are required to find acceleration. We take a big gradient of the straight line, big triangle, more accurate, right? Because you have to read it. In this case, it doesn't really matter, right? You will still get the same answer. Gradient of straight line. Right? This is 14. This is 6. 14 minus 2, that is 2. 6 minus 0. In your calculator, 2 meters per second squared. Right, then you need to know from the velocity time graph how to find the displacement. It's just the area under the graph. Area of trapezium, triangle, and rectangle. Okay. So it's 14. Parallel side is 14 plus 2 divided by 2 and times the perpendicular distance. That's a perpendicular distance. This is a 0. 6. So we get 48 meters. Okay, so that's the formula form to help you remember. Displacement from velocity time graph is area under the graph. Right? Non-uniform acceleration, you must be able to distinguish what is uniform acceleration, what is non-uniform acceleration. Straight line, velocity time graph is a straight line, uniform acceleration. Non-uniform is a curve. Right? Remember the slope increases. So this is acceleration. This part, the slope decreases. So it's deceleration. Right? We'll go into more of that. You just need to know if it's a curve, non-uniform acceleration. Right? Remember, acceleration for velocity time graph, acceleration is the gradient of tangent to curve. Okay, for this case, where the speed is decreasing, right, it's moving in a straight line, we can call it can call it uniform acceleration. Acceleration. In this case, the speed is increasing or the velocity is increasing. It's traveling on a straight line. Whereas this one, the speed is the same. Sorry. Yeah, the speed is the same. 60 kilometer per hour, 60 kilometer per hour. Right? Speed is the same, but velocity changes. Remember, as long as the direction changes, velocity changes. Right? Here, speed is increasing, so it's accelerating. This one is also accelerating, right? Because acceleration is vector. So we don't look at the speed, we look at velocity. Even though the speed is the same, but the direction of velocity changes. So it's accelerating. Right? Moving in a curved path with constant speed, but changing direction or velocity changes. Right? Wherever the speed changes direction, velocity changes. It's accelerating. This one, it starts with high speed, decrease to a lower speed, or high velocity to low velocity. So we give it a special name. It's still acceleration, but give it a special name, deceleration or retardation. To say it's a decreasing speed. Okay, so the object is accelerating when the magnitude or velocity changes or the direction of velocity changes. Not speed, right? Velocity. Magnitude is just the speed. Magnitude of velocity changes is the speed changes as well. But acceleration is vector. So where the velocity changes, the direction changes, it is accelerating. Equation of uniform acceleration will be derive later on. There are 4 of them. Okay, we use it later also. Then you need to remember them. One way to remember them is to do exercise. U is the initial velocity, V is the final velocity, A is the acceleration, T is the time taken, S is the displacement. Right? Remember, these are vector equation. Only time is the scalar. Assumption, before we can use this formula, we must know that acceleration is constant. Then we can use the formula. Right? Or another way of saying there's no air resistance. Right? Of course, modern textbook will tend to have this one. We don't need to worry about this extra formula. You can use these formulas enough already to calculate what you want. Okay. So, summarize for what you have learned. Constant displacement with time, stationary. Right? Uniform velocity, in this case, right? It's the stationary. Uniform velocity, displacement time graph is a straight line. Right? That's what I mean by uniform horizontal line. Velocity time graph, horizontal line. Okay, we will be drawing this style of graph is uniform acceleration. You need to recognize and remember them. Right? It's a parabola. There's no air resistance. That's why we have uniform acceleration. Dropping an object in vacuum. Velocity is a straight line. Acceleration is constant. Right? Increasing and decreasing acceleration. You should be able to recognize this is a speed time graph or velocity time graph. The same. We always look at the gradient of tangent to the curve. So this one, the red one, the slope is increasing. So the tangent is increasing, so it's accelerating. Acceleration. Whereas the blue one, the slope, we call it deceleration. Right? Slope, smaller and smaller until it's all is zero. No acceleration here. So we call it, gradient is decreasing. right? So we call it deceleration. Okay, a ball being thrown upwards. That's a picture of it. Remember, we just displaced it. It's actually on the same line, right? On the same straight line. A ball is being thrown upwards with velocity 20 meters per second. So this one show you a big vector there. Distance is measured from the end there, times 0, 20 meters per second, right? And remember, velocity is a vector quantity. So we have to choose upwards as positive or upwards as negative, right? So in this case, we choose upwards as positive, right? And if you observe, this velocity decreases. And at a height of 15 meter, it reaches 10 meters per second. And it decreases to further at the maximum height, the velocity is 0. Right? We can calculate it on that the height is 20 meter, velocity is 0. At the maximum height, velocity is 0. Then it reverse direction. After that, it's accelerating. This one is decelerating when it's going up. When coming down, it's accelerating. So same height, right? You can, same height, we have same speed, except we put a negative sign because it's a vector. Velocity is downwards. Right? We choose upwards as positive, downwards become negative. So when it reach the hand, again, right? 0 displacement, it must be 20 for the speed, but because it has a direction downwards, we put negative sign there. Okay, the speed is 20, I reach the boy's hand. We put negative there to show its velocity is downwards. Right? Remember, we choose upwards as positive, so acceleration is downwards. It's always downwards, never disappear. Even though velocity can be 0, acceleration is always there. Right? So it's always downwards there. And wherever you draw, it's the same value. Up or down is the same, always negative. So we are asked to draw a graph. There's a graph that we draw. 9.81. Always the same throughout the whole journey. Acceleration time graph for uniform acceleration. For the whole journey, the acceleration is always downwards. Velocity changes direction and magnitude, that's all. Speed changes in magnitude. Okay, we will be drawing this graph. A stone is dropped from rest, vacuum at a height h. Sketch the displacement time graph for the motion. We're dropping a stone in vacuum. Sketch the height against t squared. How do you obtain the acceleration of the free fall from the graph? Okay, let's just try solve some problem. Right? For O level or STPM is straightforward. Like this one, give you a graph. Graph shows the progress of athlete in 100-meter race. What time was taken to travel 10 meters from the start? Right? So STPM or O level, more getting you to read, know how to read. At 10 meters there, draw a line and then read the time. Right? So answer is B, 2.8 seconds. Right? Each small square is 0.2. It's 2.2, 2.4, 2.6, 2.8. Right? A level, big further. Velocity at 7 seconds. Right? If this distance, then we calculate speed. If that's displacement, then we calculate velocity. Right? Let's draw a line there. 7 seconds. Draw a tangent there. A line touching at this point there. And 7 seconds there. Right? Draw a big triangle. Right? 98 here. Right? This one is 2. This small square is 2, so it's 98. This is 14. You can read here 4. And then this is 10. Right? So velocity is a gradient tangent to the curve. So it's 98 minus 10, 14 minus 4. Using a calculator, calculate out. Right? It's also a A-level question to refresh your memory. A tennis player hits the ball hard at 0.4 seconds. Later, hears the echo. Then he hits to make the sound. So the sound travels from him to the wall and then come back to him. So distance from him to the wall is the same. The speed of the sound is 330 meters per second. How far is the player from the wall? Right? So remember, first thing is to let the distance from the tennis player to the wall be x. So he traveled 2 distance. Right? Distance is speed times time. So total distance traveled is x plus x is 2x. Speed is 330. Time is 0.4. And calculate your distance. Right? The sound is traveling to and fro. So that's the reason why we have 2x there. Calculate x divided by 4. Using the calculator, again, answer. A man walks 30 meters north. Right? You can draw a picture so you can help you picture what is happening. 30 meters and then 6 seconds and 40 meters west, 10 seconds. Total distance, we just add them up. Not worry about direction. 30 plus 40, 70 meters. Okay, same picture as before. Displacement, we are interested where you start and where you stop. Where is your displacement? R, the resultant vector. These two vectors. There's a vector, there's a vector. R, the resultant vector, is the displacement. Right? Remember, displacement is a vector, so you must have not only magnitude, direction. Displacement, right? Using Pythagoras theorem, 30 square plus 40 square, and then square root the whole thing, get 50 square. 50 meters, sorry. And find the angle, direction. As long as you show the angle is clear already, no need to go and define north, how many degree where. Right? So on the drawing, tangent theta is 40 divided by 30, and then use your calculator, 53.1, 53 degrees. Okay, now we are required to calculate the speed. Right? Speed, we always go back to the distance. Average speed, distance over time, total distance over total time. Right? This is 6 seconds, this is 10 seconds. So 6 plus 10, 4.4 meters per second. Right? Average velocity. Okay, average velocity, we just take the displacement over the time. Time is still the same. Right? Displacement over time. So it's 50, displacement is 50, divided by time is 16. Get the answer. Right? Direction is still the same as the displacement. Right? North, 53 degrees west. Displacement time graph. Okay, there is a change in distance, change in displacement, time interval, or change in time. Right? During that distance that is traveled. So you should be able to recognize what type of motion is this one. Uniform velocity. What does the gradient represent? Right? Correct, velocity. Then determine the velocity of the moving object. Right? A big triangle. 3 and then 60 there. 0, 0. So gradient is 60 divided by 3. Right? Or height divided by base. 20 meters per second. There's a velocity time graph. Uniform velocity, horizontal line. Since your calculator value, put a value there. If not, horizontal line good enough if they ask to sketch. time interval is 1 second. Then you need to know what's the area represent. Right? You can use your S is V times C. So area is the area. Or calculus, using calculus, much more easy to understand. V times T is the area. Right? Give you an example. Car moving in a straight road at constant speed. Right? If you're able to describe the motion, distance time graph, this part, horizontal line means stationary, at rest. Right? Curve this way means the gradient is decreasing. Gradient of tangent to the curve is decreasing, so it's decelerating. This part is a straight line, so it's uniform speed or uniform velocity. Right? This part, the slope starts from zero, increasing to larger value, so it's acceleration, gradient increasing. Right? So you should be able to describe the motion. In this case, describe the motion of the object, acceleration, uniform velocity, deceleration, and stationary, or it stopped. A. Okay, displacement time graph. Describe the motion, right? You should be able to describe. This is uniform velocity until 5 seconds. Then after that, in reverse direction, uniform velocity, right? Greater value, greater gradient, greater value for velocity. Then you return to the origin and then go to the negative x direction. Okay, that's how we describe uniform velocity in positive x direction for 5 seconds. Then reverse direction, move with greater uniform velocity to the origin. That's the origin. Then continue in the reverse direction. That means negative x direction, uniform velocity. Right? And if you're asked to describe greater uniform velocity compared to the previous velocity, it is greater in magnitude. Right? Greater uniform velocity. What's the velocity of the man during the first 5 seconds? First 5 seconds is just here. Right? Velocity is gradient of straight line. So it's 10. Right? It's 0. The height is 10. Base is 5. 10 divided by 5. So it's 2 meters per second. Where is the man? At 9 seconds. You just read only. 9 seconds, read on the ground there. It's about 8 meters. Negative x direction. 8 meters in the negative x direction from the origin. Right? This is an A-level question, an O question. Right? Should be able to write to describe the motion. Right? Remember, displacement time graph. We take the gradient. Velocity can be obtained from the gradient of the straight line to the curve, of the gradient of tangent to the curve. A and B, stationary, horizontal line. C and E, C and E, right? This is reverse direction, but it's uniform velocity. B is the curve. So the slope is changing. So it's accelerating at B. The answer is B. Right? So describe the motion of the vehicle. You should be able to describe stationary, uniform acceleration, uniform velocity, decelerating, uniform velocity, sorry, stationary, reverse direction, as uniform acceleration, uniform acceleration in the new direction, uniform velocity, and return to the origin. Okay, a racing car accelerates through 3 gear changes with the following average velocity. Right? So it's 20 meters per second is the average velocity during that time. 40 meters per second is the average velocity during that time. And then 60 meters per second or 6 seconds. What is the overall average speed of the car? Right? Remember, average speed is the total distance over total time. So we have to find the total distance it has traveled. Okay, distance is speed times time. Total distance 20 times 2, 40 times 2, total distance travel 60 times 6. At total distance 180. Average speed, total distance divided by total time. Total distance is 480. Total time is 2 plus 2 is 4, 4 plus 6 is 10. It's 48 meters per second. Right? Accelerated motion. State the type of motion. You should be able to recognize this is uniform acceleration or steady acceleration. Not speed, not velocity. Right? Velocity is changing. Give an example. Right? There are many examples. Dropping a ball in vacuum. Example of this type of motion. What does the gradient represent? Let's memorize. Right? Acceleration. So determine the acceleration of the object. You just draw a big triangle, right, to reduce the error in reading. So delta V, this is a delta V. Right? This is delta V. This is delta T. So 40 divided by 4. 10 meters second minus 2. Okay, we want to draw the displacement time graph of this motion. And this is a velocity time graph. So what does the area under the graph represent? Displacement. The area, displacement is V times T. Right? If that will help you. So you have been filled up for you the first one. Area under the graph is half 10 times 1 is 5. So the next one for this one, 2, right? 20, that one. 20 half area of this triangle, 20 times 2 divided by 2. And then for 3 seconds, that's a 3 second. Right? Area under the graph is half times 30 times 3. So I get 45. Right? So that's for 2 seconds, area of the triangle. So I get 20. Right? For 3 seconds, area of this triangle. So I get 45. And after that, you just sketch the graph. Right? It's a parabola. Okay, sketch the graph, you just draw the point, put the points there and then draw the graph. How would you determine the velocity at 2 seconds? Right? At 2 seconds, gradient of tangent to the curve, right? Determine the velocity using a straight line, a tangent to the curve, and find the gradient. Okay, there's your delta x, change in x, change in time. Okay, can read it. 4, and then this is 60. This is 1, and then no height, so 0. I can find triangle. Velocity is gradient, delta x or delta t, 60, 60, right? 60 minus 0, 4 minus 1, so it's 20. Okay. Define acceleration. This one must be in your head. Memory work. Right? It's not a ratio, it's a rate. C. Rate of change in velocity. A body starts from rest at t equals 0 and move with uniform constant acceleration. S is a displacement and t is a time. Which graph best represent how S, the displacement of the body, varies with time? Okay, so either memory work or you can read from the graph. The slope is increasing. So the slope is decreasing. This is where you have air resistance. The answer is B. Object travel at a constant speed of 20 meters per second for the first 10 seconds. During the next 5 seconds, it accelerates, right? Show for you, accelerate uniformly to 20. So from 10, it accelerates to 20. What is the total distance traveled by the object? This is an O-level question. Right? Area under the graph. Distance travel, area of rectangle, area of triangle. Right? Area of rectangle plus area of triangle. Area of rectangle is just your 15 times 10. Area of triangle is just that height there. That height is 20 minus 10. 20 minus 10. That base there is 15 minus 10. Half it. Right? Area of a triangle. So you get B. Right? So you must always remember, object is moving with uniform velocity or steady speed. Steady speed, that's what is happening. Uniform speed, steady speed, and uniform acceleration. Right? Or another way of saying is no acceleration for the first 10 seconds. Then after that, uniform acceleration. Okay. So your distance time graph or displacement time graph, right, is still moving forward. So this part is a straight line, uniform speed, straight line. After that, accelerating, it should be a curve. Then sketch the acceleration time graph. Right? No acceleration, zero acceleration, zero acceleration. And this part there, right, uniform acceleration. So it's a horizontal line. Right? You calculated 2, so we just write 2 there. What's the acceleration at 12 seconds? 12 seconds is here. So it's just this straight line. Acceleration is the same during this time interval, this straight line there. Right? Acceleration is gradient of straight line. Gradient is, I can take 20 minus 10, that's the height. And then 15 minus 10 is the base. Minus 10. And use calculator or work mentally. 10 divided by 5 is 2 meters per second square. Okay. So we have completed this one. Right? The next video we prepare will be we'll look at the equation of uniform acceleration. So I will stop here. Have a good day.